So today I'm explaining to you about quadratic equations and some basic quadratic polynomials you have already done. And the second chapter, now this is quadratic equation. Now there is a confusion between polynomial and equation. The simple format that we have to remember that a quadratic equation is in the format of ax squared plus bx plus c equal to 0. If there is an equal to 0, that becomes an equation. If it is only ax squared plus bx plus c, then that is a quadratic polynomial. So equation means it has to be equal to something, and this is the general form of a quadratic. So if you are having an equation 3x squared plus 5x plus 2 is 0, this is definitely a quadratic equation. Because it's in this format, the highest power of x has to be 2, and that is why it is called quadratic, and it is an equation because it is equal to 0. Now, when we solve quadratic equation, what we traditionally were doing was solving this by factorization, by splitting the middle term or using identities. We can do that, but remember, all questions cannot be done by using splitting the middle term or factorization, and therefore we use a method which is called the quadratic formula. Right? So this is a very, very useful method for those students who find splitting the middle term very tough. Okay, because if the numbers are small, you are able to find, but if the numbers are large, it becomes difficult for some of you to find the factors. So this method, quadratic formula, I'm going to explain. Now see, if I am going to try to split it, 3 into 2, 6, the product has to be 6. And when you add, you have to get positive 5. Okay, so can you think of two factors which on multiplying is giving me 6, but on adding will give me 5? The factors, if you think you are able to do, then you can do it. But here, remember, the product is 6. So that is 3 into 2. And when you add, you have to get, so 3 and 2. So this case, it's very easy to find the factors because it is, these numbers are very small and you could easily find out the factors. Okay. But there may be questions where you may not be able to find the factors. Let's say we are having an equation 7x squared plus 2x plus 3 is 0. Okay, 7 into 3 is 21. When you add, you will never get 2. Okay, the product is 21. We can get 7 into 3. But on adding, we should get 2. So we cannot do this by splitting the middle term. So when we are having questions like these, then we use quadratic formula. But remember, in quadratic formula, there can be cases where the roots cannot be found at all because the roots are unreal and we are doing only real roots right now. So first thing that we have to do is find out something called the discriminant. Okay, find out something called the discriminant. Discriminant is equal to b square minus 4ac. This is the discriminant. Discriminant is b square minus 4ac. So what is ABC? A is the coefficient of x square. So what is A? A is 7. What is B? B is the coefficient of x. B is equal to 2. And C is the constant, that is 3. So A, x squared. That means the coefficient of x squared is A, coefficient of x is B, and C is the constant. So how do we find ABC? From the equation I have explained just now. So A is 7, B is 2, C is 3. D equal to B square minus 4AC. We get 2 square minus 4 into 7 into 3. So this is going to be 4 minus 7 into 4. We get 28. 28 into 3, we get 84. And when we subtract this, we are going to get negative 80. Okay. So one very important thing that we have to understand in this chapter is that if the value of the discriminant is less than 0, then roots are unreal. We cannot solve this. Unreal or imaginary roots is not in our course. We will say roots are unreal and leave it as it is. That's it. Just like in linear equation, we had no solution. Okay. And if D is greater than 0, then roots are real. Roots are real and distinct. That means you're going to get two answers. We are going to get two answers, and both of them are going to be different from each other. And D can be equal to 0. Here, roots are real and equal. That means we will get two answers, and both of them are going to be equal to each other. Okay, so these are the three cases. So unreal roots we cannot solve. Now let's say another equation I'm giving you, 3x squared minus 5x plus 7. Okay, I'm giving you 3x squared minus 5x plus 7 and I'm telling you to solve. So what will be A here? A will be 3, B will be negative 5, C will be 7. Let me find out D. D is equal to B squared minus 4AC. So this is going to be negative 5 square minus 4 into 3 into 7. So this is going to be 25 minus 4 3 is 12, 12 into 7, 84. So again, you're getting negative. So you will not be able to get the real roots. But suppose instead of minus 5x, now suppose I am changing this question to, let's say 3x square minus 5x, and I am putting plus 7 as minus 7. Do you think there will be a change now? There will be a change. Look at this. A is 3, B is negative 5, C is negative 7. When you calculate the discriminant, B square minus 4AC, it's going to be minus 5 square minus 4 into 3 into negative 7. Okay, take the signs also into consideration. So this is going to be 25. Both these are 12, 12, 7 are 84 plus 84. And what is happening when you add this? You are getting 109. So what has happened? Our discriminant value has now become positive, greater than 0. So here when we are solving, we are getting negative. So these we will say unreal roots and we don't solve it. But when we are getting greater than 0 or equal to 0, then we have to solve it. Now, how are we going to solve that? So as I told you, when d is greater than 0, roots are going to be real and distinct. And what are the roots of a quadratic? They are represented by alpha and beta. And the quadratic formula says alpha is equal to minus b plus square root of the discriminant, right, upon 2a. And the value of beta is minus b minus square root of the discriminant upon 2a. So this you have to memorize. Okay. Alpha is minus b plus d, that is it, or b square minus 4ac. You can either take it out initially or you can substitute here, no problem. Minus b plus root d. So minus b. So if I'm taking this question, what is my minus b? This is already negative 5. So minus of minus 5, right? Plus root d. So root 109 upon 2 multiplied by a value is what? 3. So 2 into 3. So what is my answer? 5 plus root 109 upon 6. So this is my first answer. 5 plus root 109 by 6. So don't get worried about these type of answers. See, if it is a perfect root, you will solve. But if it is not a perfect root, you can leave it like this. No need to find the answer in decimals. Okay, leave like this. And beta value will be the, see the difference. Here it's positive, here is negative. The only difference is in the sign in between. These are called conjugates. So if one root is this, the other root will only differ by the negative sign in between. Sometimes in 1 mark question, they can give you this, that one root of a quadratic is 5 plus root 109 by 6. What is the other root? So if alpha is this, beta will be minus b, that is minus of minus 5, minus root 109 upon 2 multiplied by a, that is 2 into 3, that is 5 minus root 109 upon 6. So you see the difference is only in the positive and negative sign. So this is how we can solve all questions of quadratic. Any quadratic equation, even if you know how to split, then fine. If you don't know how to split, use the quadratic formula. It's slightly long, but definitely you will get the answer. So again, I'm repeating this. First, find out ABC. Find out the value of the discriminant b square minus 4ac. See whether it is positive, negative, or 0. If it is negative, just write that roots are unreal or imaginary, cannot be solved at this stage. Okay, later on we have methods to solve it. You will say roots are unreal. This part we need not solve. We will just leave it as it. If it is a positive number, if discriminant is positive or 0, then I will use these methods, alpha and beta formula, and I'm going to get 2 values. And that's why we say roots are real and distinct, because I'm getting 2 answers. Remember, in a quadratic, we will always get 2 answers. Okay, quadratic, the highest power of a quadratic equation, the highest power of the variable is 2, the degree is 2, therefore we'll have 2 answers. If it is a cubic equation, you will get 3 answers. If it is a 4th power equation, we'll get 4 answers. Okay, linear equation, we get 1 answer. So this will always have 2 answers. It could be distinct, or if discriminant is equal to 0, then we will get 2 equal answers. Okay, so I'm the textbook questions, you can very easily do it. I'm discussing with you 2 little difficult questions, not difficult, but you should know how to solve it. So these are little tricky questions. You can note down this. This is especially useful for those who are giving standard maths. Okay, so the first question that I'm going to discuss, 1 upon a plus b plus x is equal to 1 upon a plus 1 upon b plus 1 upon x. So this is a hot favorite among the people who make tests, whether it is in schools or whether it is for the boards. This is an important question, especially for the standard students. Now, the first mistake that people do is generally start taking the LCM here. That is a wrong approach. Always remember, when you try to solve an equation, bring the like terms together. So there's an x term here, bring this x. We are solving for x. So bring the x term on one side. So we are going to get 1 upon a plus b plus x minus 1 by x is equal to 1 by a plus 1 by b. Okay, we are bringing the 1 by x this side. Step number 1. Now the next step, I'm going to take the LCM. So LCM will be the product of the denominators, a plus b plus x into x. This x is going to be multiplied with 1, so I get x. And these are going to be multiplied with negative 1. So minus 1 has to be multiplied with a plus b plus x. I put it in brackets because signs are going to change. Here I'm going to take the LCM AB. So this is going to become b plus a, right? In the next step, I'm going to open the bracket. So 1 into anything is the alphabet itself, but there's a negative, so signs will change, minus a minus b minus x. Denominator I'm going to open, this will become ax plus bx plus x square is equal to b plus a upon ab. X and minus x will get cancelled. Now here minus a minus b, we can take negative common. Inside the bracket we get a plus b, and here I am going to write as it is, no difference. I will write this as it is. This is equal to b plus a upon ab. Now, what do we realize? That a plus b, the numerators are same. So numerator I can cancel, a plus b. And now I'm going to cross multiply this. So this is going to be x square plus ax plus bx is equal to ab. And there's a negative sign here. So ab into negative 1, you will get minus ab. Remember, a plus b has got cancelled, but there's a negative sign which is left here. So you're going to get negative ab. The negative ab now I'll bring on the left side. So what will happen? This will become positive ab. Now I'm going to take common. Common here is x, so I get x plus a. And what is common here? I'm going to get b common, x plus a. Always remember, if your factorization is correct, your brackets have to be same. Whether in splitting or in any method, if the brackets are not same, factorization is not same, then that means you have taken wrong factor. So I'm getting the same brackets. That means my factors are right. So here I'll combine this, I'll get x plus a and x plus b as 0. Equate each of the brackets to 0, and therefore what will happen? I'm going to get the value of x as negative a and negative b. So these are my answers. X is minus a and minus b. In some books, reference book, you will also find instead of a and b, p and q. 1 by p plus q plus x is 1 by p plus 1 by q plus x. Procedure is entirely same. So there you will get x as minus p and x as minus q. So please note this as an important question and note the step that we have done here in the first. Bring the 1 by x on the left side and then I start solving this. Right? So hope you understood this. The second question that I'm going to discuss today is a question like this. Equation is given a minus b x square plus b minus c into x plus c minus a is 0. Okay, this is a quadratic because the power of x is 2. Question is prove that 2a equal to b plus c. Again, an important question for standard maths which can come under parts. So a minus bx square plus b minus cx plus c minus a equal to 0. Prove that 2a equal to b plus c. Okay. So first, as I explained in the previous, let me find out the value of the discriminant and see what is the value of the discriminant. So d equal to b square minus 4ac. That is the formula by which I will find. So this becomes my a, this is b, this is c. Okay, this is my a, this is b, and this is c, because that's the format. Now b square means we'll have to square the coefficient of x. So this is going to be b minus c whole square minus 4 into a value is a minus b, into c value is c minus a. Okay, so roots of this equation I am going to find out. So b, when I am solving this, what will happen? This is going to be b square plus c square minus 2bc, isn't it? A minus b whole square I am applying here, minus 4, and I am going to open the bracket. A into c is ac, a into minus a we get minus a square, minus b into c we get minus bc, minus b into minus a we get positive ab. You're multiplying each term with each. You're multiplying each term with each. And then when we solve this further, we get b square plus c square minus 2bc minus 4ac. Now I'm opening the bracket, plus 4a square plus 4bc minus 4ab. I have to change all the signs because the negative sign is here. So I'm going to do some rearrangement here, b square plus c square plus 4a square as it is. Then do we have any like terms? We have AC here, BC here, and again a BC here. So these two are like terms. So this I can write plus 4BC and minus 2BC is positive 2BC. Then we have minus 4AC and then we have minus 4AB. And if you read the question in this, it is given that the roots are equal. If the roots are equal, that means the discriminant is 0. Last time I explained in the previous case where what is the value of the discriminant greater than 0, roots are real and equal. If it is equal to 0, it is roots are real and equal. So here the roots are given equal. Okay, roots are equal given. So the value of d is 0. So that means I can equate this to 0. Now look at this very carefully. This is a formula which you have done in class 9. So many of you may not be recollecting it. This is actually a square plus b square plus c square plus 2ab plus 2bc plus 2ca. That is the formula of a plus b plus c whole square. Okay, a plus b plus c whole square was a square plus b square plus c square plus 2ab plus 2bc plus 2ca. This was the formula. Okay, so if this is the formula and we need to apply this here, then what am I going to write this as? I'm going to write this as, now see, here we have two negative terms. In the negative terms, this is minus 4ac, this is negative 4ab. Which alphabet is negative? That we can find by what is common. So a is here, this is 4ac, this is 4ab. The alphabet that is common is a. That means a value is negative. The others are positive. So I can write this as b square plus c square plus minus 2a whole square. Okay, a square plus b square plus c square plus 2ab. So that's going to be 2 into b into c plus 2 into c into minus 2a. I'm using this formula, okay, twice of ab, twice of bc, and twice of ca. So 2 into minus 2a into b. So what is happening now? I've got this format, a square plus b square plus c square, 2ab, 2bc, 2ca, and I'm getting this. So what can I replace this? I can replace this with b plus c minus 2a whole square. So this is our most important step, b plus c minus 2a equal to 0. Now if b plus c minus 2a whole square is 0, if the square of a number is 0, that means the number itself is 0, because there can be no number whose square is 0 unless the number itself is 0. So therefore, we can say that b plus c minus 2a is 0, and b plus c minus 2a, I'm going to transfer this side, I'll get b plus c is 2a, and this is what I had to prove that 2a is b plus c if the roots of this quadratic equation are equal. Roots are equal. So discriminant was 0. I applied that formula, and this is what I applied here, this identity which you did in class 9, a plus b plus c whole square. Using that, I got this, and once I get this, I'm able to prove this.